In this video, I'm going to be talking about the importance of optimizing your shading and materials for animation. When you're rendering stills, it's not so important because you're usually only rendering 1 or 2 frames. But when you're rendering 24 frames a second in HD, every single second of render time counts, especially when you're going to be doing a lot of test renders, when final sequences have retakes because things have been changed. Render time really begins to count a lot, especially when you're working on a large production. The larger the production, the more the render farm is going to be blocked. It's really important to, from the very beginning, have the right mindset and try and squeeze every ounce of performance from your shading. And to demonstrate this, I've got my Android character here. And on his head, I've got two materials which are being blended together with a mask. So inside this group, there's one material with some maps, and there's this map here which is masking between this material here and this material below it in the shader tree. And I've done a test render, and in HD, it's at 1920 by 1080, it's taken 2 minutes and 42 seconds to render, which doesn't seem too bad, but bear in mind this is very simple. There's only an environment HDR and the model itself. But now I'm going to compare this with a completely different setup. So I'm going to close the group and I'm going to disable it. And beneath it, I've got a different setup where there's only one material, no blending between two materials, just one material, and then some maps which basically define exactly how specular and how rough each part of the model is. And these maps were hand painted in Mari. So I'm going to do a test render, just pause the video while it's rendering, and we can make a comparison between this setup and the previous one. And here is the completed render. And whereas the previous render took 2 minutes and 42 seconds to complete, this one only took 1 minute and 40 seconds. So you can see that by making a simple change to the way my material was set up, I've substantially reduced the render times. And this makes a lot of sense when you think about it, because by asking the render engine to calculate two materials and blend between the two of them, there's going to be far more calculations than when the render engine is just dealing with one material. And while at this stage, the small difference in render time between the two different setups might not seem such a big deal, you have to bear in mind that this is going to scale up as the scene complexity increases. Once the character is being used in real production scenes, this small difference is going to get larger and larger because they're going to scale up proportionally. So the material that renders faster now in the simple test scene is going to render much faster in the real world production scene. And this also means that before your assets enter actual production, before they go into lighting, for example, while they're still just being worked on as textures, and when they're published, you should try and keep all of the quality settings as low as possible. You want your shading rate to be as coarse as possible, your reflection rays to be as low as possible. You only want to raise them on a case-by-case basis once the scenes and the assets are actually in production. When you see noise in test renders of shots that are works in progress, then dive in and increase the quality. But you don't want your published assets to have all their quality settings maxed out, because that's a really inefficient way of working. You want everything kept as low as possible so that initially your renders can happen as quickly as possible. That means that you only increase the quality settings when you need to, and you use your render time in the most efficient way possible. Now, of course, this doesn't mean you should be publishing noisy assets. Typically, when you're working in shading, you're working with a very simple lighting setup. In this case, I've got an HDR and a directional light, so it's as simple as it gets. And I know that if I'm going to see noise issues in a setup as simple as this one, once the asset gets into production, the noise is going to be even worse. So if there's any obvious noise at this stage, I would fix it before publishing the asset. Because otherwise, once the asset gets into production, every single lighting artist would have to fix the same issue for every single shot. That doesn't make sense. It would be a huge waste of time. So really obvious problems should be fixed at the publish stage. But what you shouldn't do is to go through and max out all your quality settings just in case, because that's a really inefficient way of working. It means you're going to get very long render times, and render time is also quite precious. So the idea is do just enough for it to look good at the publish stage, and then deal with additional problems that you're definitely going to encounter on a case-by-case basis, because you'll find that things are going to vary shot to shot There are going to be some shots where everything is going to be fine, and on more complex shots where maybe there's more complex environments around the characters, there you find that you're going to run into specific noise issues, and these should be fixed for that particular shot. And so one of the strategies for getting the most efficient render times possible goes back to a point I made earlier. You want the render engine to do as little work as possible. And if that means that you do a little bit of extra work ahead of time, or at least some extra planning ahead of time, then that time will be well spent. And a case in point would be the head of this character. I've got what appear to be 4 completely different looking materials going on here. I've got the paint on the front of his face, and underneath that I've got a rusty metal with hardly any reflection on it at all. On the back of his head I've got a different kind of metallic effect, and the scratches there are revealing a greyer metal underneath. And yet all this variety is being controlled by one material with 5 image maps and 2 procedurals, and that is enough to create these 4 different looks on the one object. And this is where the idea of planning ahead really comes into its own. I'm going to switch to Mari to talk a little bit about the thinking that went in behind creating these textures. I knew that I was going to want to control everything with one material, so I concentrated on doing all my masking and my blending within Mari rather than letting the Modo render engine do it for me. This meant that I painted my maps knowing that I was going to need to control all the different properties within the actual textures themselves. And this is why I created the blends between the different materials here at the texturing stage rather than doing it within Modo at the render stage. And this applies to my color map, but all my other maps. So I created bump, roughness, displacement, all within Mari. And you can see that I've used quite a few procedurals, for example, at this stage, but I was sure to use them within Mari as much as possible and then bake them to the texture maps, which I then exported to Modo, so there'll be less calculations going on at the render stage. Another aspect of optimization which you should definitely consider is baking complex procedural textures. Now this especially applies to occlusion, but it could also apply to other procedurals, especially if you've got a really complex stack of them all blended using different blending modes. So in this example I've loaded this mesh from the standard content, and I've got 2 occlusion textures, one on top of the other. They're both set to multiply. And below that I've also got a crackle texture set to overlay, and finally a noise texture. And these are all set to diffuse color. And I've done a test render, and if I open it you can see that at full HD it's taken 6 minutes and 26 seconds, which is a pretty long time considering that there's only one asset in an empty scene here. Now all of the overhead here is coming from the 2 occlusion textures, because rays have to be fired to detect where the occlusion is occurring, and this is going to happen on every single frame, so it is going to be very costly. So what I need to do here is to bake all these 4 different diffuse color textures into a single image map and apply that to the mesh instead. So the way you go about this is you go to the topmost of your textures that are set to the same type and go to Add Layer, Image Map, New Image. And here you just choose a file name, so I'm going to call it bake.png. And click Save, and then you set your dimensions. So I'm going to set this to 4K. Format RGBA, so it's got an alpha channel, and I'm going to leave everything else at default. And at this point, Modo is going to create the new file, and all you need to do in order to actually bake all the texture information to this new map is to right click on it in the shader tree and click Bake to Texture. Now just bear in mind that a complex bake like this one, where there's 2 occlusion textures involved, can take quite a long time. In fact, at 4K on my machine, this particular bake took 5 hours, but it's going to be well worth it, and I'm going to show you why. So for now, I'm just going to disable this new image map I've just created, and I'm also going to disable these procedural textures. And what I'm going to do is I'm going to enable this bake that I did earlier, and I'm just going to pause the video while I do a test render. And this is the completed render, and just look at that render time, 4.6 seconds, as compared to 6 minutes and 26 seconds. For exactly the same result. So you can see that even though the initial bake may have taken 5 hours, that time was really well spent, because over the course of hundreds of frames, I'm going to gain a lot of time with the way that this asset is now shaded.